In this video, I'll be showcasing how I created this motion graphics thing for a client. Basically, he has shown similar other work, perhaps created in After Effects, and wished to highlight his portfolio of work in the same fashion. I decided to give it a try on Houdini instead, and Houdini provided the solution like nothing else. The procedural workflow lets me to change almost anything instantly. The number of images to display, the number of structs connecting these. The client wants something different, just change some inputs and we have the desired results. Okay, so let's start in Houdini. Let's take a sphere and we are going to distribute some points inside it. And the way I can do is through ISO offset node. Now that the volume has been created, let's distribute some point. I would think I need to scatter some 40 points. It all depends, so you can change it to whatever number of the images you want to display. Let's add an attribute wrangle. Okay, semicolon at the end. And now when you press this button here, this will create an offset slider for us, and as I move this slider you can see that the points are animated. Now just so that you can see these points clearly, I can increase the size of these points in the viewport. So let's press D, and inside in the geometry tab I'm going to increase the point size here. This is just for the display purpose. I'm not increasing point scale values. This is just to better visualize in the viewport. So now these points, for these points let's add a keyframe at frame number 1, and then I think at frame number 15 I will increase its value say to 2, and again alt click here to add another keyframe. As you can see, these points are moving. Sorry, I have done the offset value of 1 here at the frame number 0. Sorry, this is going to be 0 value at frame number 1. Okay, again alt and click here to get a keyframe here, and yeah, we are getting a good position changes. Now one thing, this is very uninteresting, dull animation happening. All I need to make sure that these points they move a little random. The way I can do so is just by adding a color attribute, and then I will randomize this attribute randomize. We have randomized this color attribute, and all the colors for every other point it has changed. This can be a good varying factor for offsetting the positions. And now in the attribute wrangle, if I add, you will see that yes. Okay, now one thing you might have noticed, that once this points reaches this final destination, it just freezes there, just hitting a wall there. Just to make it a little more interesting and lively, I think we need to add a little offshoot to it. Then the points should return back a little bit of springiness to it. And I'm not going to use keyframe animation for this, just add a chop network. Let's dive inside. First we will bring the geometry and then add a functionality to it. And here you can see that you have got some options here. This is the overshoot. You can increase the value here, 0.3 or 0.4 will do fine for us. And now whatever value changes that you have done here, you need to bring it back into this network. So let's append a channel node here, and in the channel node we need to make sure that the points, the information that's coming to us is our animated position. And now if we play, nothing is happening here. The reason being very simple. In the chop network we have not yet specified the location from where it has to fetch the transformation information. So let's click this icon here. You can see that it's really getting difficult for us to understand which node we want to fetch the information from. So it's always a good idea that first of all we should create a placeholder. So I am going to create a null node here, and I am going to rename it as out for chop. Okay, this way inside the chop network, if we click here, we can easily find the node from where we can fetch the transformation information. So accept it. This is going to be animated. Sorry, we need to add a placeholder here as well, so just add a null here, and we are going to say that this is going to be out from chop. So now here we can give a proper path, accept it, and as we play it, you can see that this is giving us a good result. Now to make this animation even more lively, let's add a little expression here, attribute wrangle, and the expression that I am going to use is this expression. What basically we are doing here is as the animation happens, timehead plays, you can see the frame number changes, and as such the sign values changes, and we are just decreasing the range here. We are adding a little bit of randomness per point. Let's add few more lines of code. This one is for y. Obviously we will have to change this value 5 4 6. I'm arbitrarily putting some values. It's okay. And then for the z component as well, z, just that this time I found that keeping making it minus worked good for me. Again we will change this value here. Now as we play the animation, you can see that these points, they are not kind of stuck at the end, they are just drifting in space a little bit. Okay, next we will take a grid and we will copy these grids onto these points. So let's take copy to points, then let's connect the nodes as such, and obviously we'll have to decrease the size of the grid here. So let's take transform node, and I think we need to give it a value of 0.05. I think even smaller, so 0.025, and then the images that I'm going to use on top of these as a texture, they are not squares but they are rectangular shapes, so I need to scale this a bit by 0.33, and also let me give a little rotation here by 90 and 90. I think yeah, 90 here as well. Also later on, since we are going to use some textures on it, so let it have proper UVs. So UV unwrap. Now the default values here are okay, and now we have to create a camera as well. So just keep pressing Ctrl key, and then as we click here, it has created a camera from this view. Okay, so switch over to camera viewport and just press this lock button here as well. As we move the camera, we would like these planes to be always facing the camera. We want them to work as a sprites. So the way we can do so is just getting some normals on the face, and have these normals always projected towards the camera. So all we have to do is just add some normals. I think normal we can add before this unwrap here. Okay, next we will have to do some maths. So let's create an attribute warp, and let's dive inside this attribute warp. Now first of all, we need to query the position value of the camera. So for that thing to happen, we will have to bring camera in this network. So let's create an object merge, and the camera is going this is the camera here. So let's plug in this camera information into the second input, but before going ahead, let's do a small change here. From the options here, let's choose this option into this object. So now let's go inside attribute form, and now we can query the position of camera. So for that, let's create get attribute. We are going to query the position value, and the file is coming from the second input. So now let's subtract the present position of the point from the coming camera position. Let me reverse this. So it's the other way actually. From the camera position we are subtracting the position value, and this value here is going to become a new normals. Basically we have to make a small change here. Instead of having this value as 90, make it 0 and 0, and instead rotate it as 90 here, or just 90. And there, as we move the camera, you will see that these planes, they are always facing the camera. However, one thing, just to give it little more better alignment, we will have to move our camera back, and then let's go in the camera settings. Let's increase the focal length here quite a bit, so the weird angle that we were getting earlier, now we have got rid of all those things. So okay, so this is working fine. However, this is not the foolproof method of orienting these planes towards the camera. Basically, on some of the extreme angles, you will find that these points might flip actually. They were going to give some weird orientations, and so this is not the correct method. Instead, we should have used a proper orientation attribute. So let's dive inside this attribute warp and get rid of this output node. So let's create a vector pointing upwards. Let's create an attribute triangle here, and let's rename it as up vector. Inside this bracket it's going to be 1 0 1 0. Okay, now that we have created a vector, let's bring it in here. Bind. This is an up vector. Type will be a vector. So we have a vector which is pointing up and another vector which is directed towards the camera. So if we multiply these two together, we find a cross product of this thing, we will get another vector which will be at right angles to this. So let's multiply these two vectors. So if we take another cross product between this vector and this vector, we now have a set of three vectors which will be perfectly orthogonal, which will be at 90 degrees to each other, and we now have we can now feed these set of three vectors which can go into forming a matrices, and later on this can become the orient attribute. Now before all these things, let's normalize these vectors first. So normalize vector, we are going to normalize the vector, not this, we are going to normalize this vector here. Let's take a copy of it. We are going to normalize this vector here. Let's normalize, I think this will go here, and let's normalize this one here as well. Now that we have the three vectors, let's create a proper matrix for that. So vector to matrix 3, the first vector which was pointing towards the camera, let's make it the third input, then let's make it the first input, and this normalized one, this is the second input, and yeah, we need to normalize it here as well. So we should have done it earlier. Just in order to validate that our maths here is working correctly, let's check the determinant value of this matrix and let's now export it. This is going to be let's name it as determinant. This is going to be a float value. So if we check here, the determinant value is coming out to be 1. If it's not 1, then certainly you'll have to check the order here, you'll have to reorder it, and you'll just make sure that the value here is coming out to be 1. So now that we have calculated a proper matrix, let's create orient attribute. So matrix to quaternion. Let's export it as find export as orient attribute. So this is going to be an orient attribute, and the type here is going to be 4 float vector. This is going to give us a lot more stable result, and even with the extreme camera angles, this is not going to flip or give some weird rotations. However, one thing, we need to rotate it by 90 degree. Before that, let's add some texture on it. So UV quick shade, and let's give it a texture. Say we want to give this texture. Okay, so certainly we need to rotate it by 90 degree. Now let's create an attribute warp again, and let's get rid of these nodes, we don't require them. We need to rotate, and this rotation needs a matrix. Now the matrix, transformation matrix, we have already calculated. We have a complete orient attribute available to us, so all we have to do is bring our orient attribute here. So this is the orient attribute, and this is 4 float vector, and first we need to convert it back into matrices. This is just the reverse of what we had done earlier. So this is quaternion to matrix. Okay, so now that we have create a parameter, this parameter, let's say this is going to degree of rotation, or degree rotation, just name it as degree rotation. Let's give it a range of 0 to 360, and this rotation accepts angles in radians. So this is something which we'll have to convert into radians first, and this goes into our angle input. Let's move back. We are going to rotate it by 90 degree, and for axis we already have a proper orient value available to us. Let me convert matrix to vector, matrix T to vector. Okay, this, and the axis, it's going to be the vector which is pointing towards the camera. I think this should work here, and this rotation value we have to convert it back into orientation attribute, or orient attribute, matrix to quaternion, and this is going to be our orient attribute. Find export as our orient attribute, orient, and this is again 4 float vector, and there we have rotated by 90 degrees. Like suppose if you say it's 45 degrees, then it's going to be like this, so, or if it's 90 degrees, then it's going to be this thing. So now we have a stable solution where it's highly unlikely that this is going to flip anytime. Okay, so now that we have the planes sticking onto these points, let's create the network like structure. That is, I want to create lines, polylines between these points. For that, let's divide these points into 2 groups. Let's create an attribute and connect it like so. This the attribute that I wish to create is ID. It's going to be an integer value. The value is going to be $pt. So that way, now if we look into spreadsheet, we will find that points have now an ID values that corresponds to the point number. Now let's randomize these attributes. Attribute randomize, and the ID that I'm going to randomize is ID. This is going to have a global scale of 1. That way you can see that ID will have a value either as 0 or it's going to be 1. Suppose that I give it here a scale of 2. Now the IDs will have a value either of 0 or 1 or 2. Okay, so make it 1 only. And now let's delete all the points that have, let's delete half the number of the points, well, approximately. And here I'm going to say $id equal to 0. So all points that had the value of 0 have been deleted. Not so, well, basically I'll have to change this to points. I think it's better if I delete everything but this thing, so that way we know that we have deleted all the points except those which has an ID value of 0. Let's duplicate it, and this time I'm going to say delete all the points which has ID value of 0, and only the points without ID value of 0 are left here. Now this side of the chain I'm going to connect them together using add node, and I'm going to say that yeah, by group, add by group, and there you can see that these points, these set of points are interconnected. Now the way I want to connect the rest of points, it's going to be a little differently. I want to connect these points with the originally scattered points, so that way these points basically, so that way when this animation happens you will have the feeling that okay, everything is evolving from somewhere. So let's reset these ID values, and I can create this attribute again, attribute create ID. This is an ID attribute, and this point, this is going to be type integer. Again I'm going to type $pt here. So here you have ID that corresponds to the point number, and this is something which I'm going to merge with the original scattered point, yeah, like so. However, let's duplicate this, add this attribute here as well. This time I'm going to connect these points through attribute, and the attribute is ID. So there we are. So when the animation plays, everything seems to be connected with the origin as intended. Now let's merge these two together, merge the set of connected points, interconnected points, as well as this new set of connected points. There we are. Now later on I found that we needed to have less number of points connected with the original number of points. Well, we need to have more number of points in this particular set. So instead of giving it a global scale of 1, let's give it a global scale of 2. So that way we can see that now we have at ID values going between 0 to 1 to 2. So that way we can see that we have less number of the points coming in this side of the chain, since it has deleted everything but 0, and we have more number of the points coming in this side of the chain. We actually want the opposite of this to happen, so let's delete non-selected points, and in this case just say that delete selected points. So that way we have more points here as compared to this. Now if we can see that, yeah, we have greater number of interconnected points. Now to just give it a little width, just add polywire, reduce the radius quite a bit. I think this is okay. Also we don't need anymore these color and ID attributes, so let's delete those attributes. Attribute delete. Okay, in here just remove color and ID. Also also we can merge it with the planes here, so let's merge these two together. Thus we have planes which are copied to the points, and these points are interconnected. They are connected like a network. Okay, so let's play the animation and check. Okay, we have word somewhere. First of all, let's just for the visual clarity's sake, I'll make the background light, or even gray background will, so no, light background, make the background light. And so now you can see exactly where we have word. So the planes, they seem to be drifting apart. The reason being is we have made a wrong connection here. This should have been connected like so. So that way. Okay. Hey, still this is not working. Yes, these points. The connection should be something like this. This is to be connected with the original points, and that way this is as intended. Okay, so next we are going to apply textures on these planes. Let's create these images, these image textures first. So I'm going to go into this material context, and in here let's create a shader. Let's create principal shader, and in principal shader just go to texture, use textures, and I'm going to use for the sake of this tutorial I'm going to use the textures that will be provided in the Houdini library. So let's take bricks here. Let's take another shader, and this time let's take, say, this texture, this metal texture, and then let's take another shader, and this time let us take this shader, this texture, sorry. So now that we have three textures, let's name them. Just name it as my texture 1. This is going to be then my texture 2, and the third one I'm naming as my texture 3. Okay, so now that we have created the three textures, let's go back into the geometry context, and now in here, first of all, I don't need these UV quick shade anymore, so let's bypass it altogether. And then if you see in the geometry spreadsheet, we don't even require these attributes anymore, so let's get rid of the point attributes, and we want to get rid of all the points attributes. So that's it, everything is fine. Yeah, some of the primitive attributes definitely we will need. So like UVs, we need UVs here. Okay, now just we will add some lines of codes at a angle. So I'm tapping these, and I will explain you later about what exactly I have done here. So what we have done here essentially is, first of all, I have randomized the primitive values, primitive numbers, and this gives me a value between 0 and 1. What since I have used three textures, just for the sake of this tutorials, I have limiting myself to just three textures. Since I've used three textures, this is I have multiplied it by 3 and then just offset it by 1. Otherwise it would have given me a value between 0 and 1. Now it's going to give an integer value between 1 and 3. And then the shop material path takes the name of this my texture 1, 2 or 3. Okay, so if you dive up, actually you will find that the texture the materials which we will be applying here, if you hover over it, you will find that the parameter name here is shop material path. So now you can understand why we have given it shop material path name here. Okay, so definitely we want to run it over primitives. However, now this is applied texture on every primitive, so obviously we will need to reduce the number of rows and column here. Let's reduce it by to the amount 2, and there we are. It has randomly selected the materials basically and applied them onto each primitive. So there we are, and that's it. Thanks.